Krishnaswamy is going to talk about Chugging Flask from building REST APIs for an Android app. Welcome, Aravind. Aravind is an entrepreneur and hands-on leader with a wide range of skills, interests, and passions.
Thanks, JV. Yeah. Can you guys hear me? Guys in the back, can you hear me? Just raise your hand if you can. Thank you. Let's just give people a minute to settle down. So I'm going to start off with just a little anecdote, which sort of tells you why I call this chugging. So about a decade back, I was traveling with our sales team to Japan. And out of the sales team, there... oh, it looks like the guys in the back could hear me. Okay. Can you guys hear me now? Better? Better? Cool. All right. So I'll start off with why chugging. About a decade back, I was on a trip to Japan with our sales team. A trip that involved a lot of late evening drinking and socialization with the team. And somewhere at some point late in the night, the sales guys come out with something which apparently is a very special drink there. They're like, you have to drink this, chug it. And this drink had a fish inside, you know. And I'm just sort of looking at it, wondering what this thing is. And they start to explain to me, and obviously English is a challenge there, right, with the communication. Explain to me that I shouldn't bite the fish, because apparently it's poisonous. And in the middle of this sort of drunken haze, trying to figure out, oh my God, I'm about to chug this drink. They're telling me it's poison inside. I shouldn't bite it. What do I do? So, well, you know, turns out at that moment, you don't really think about those things too much. I ended up chugging it without biting it, lip to tell the tale. It ended up being a specialty called a fugu fish with shochu, which is absolutely fabulous. So chugging at times is great, right? And it's, but at times there's little pitfalls that you've got to be careful about. So the background to this talk is about the backend for one of the Android apps that we built. I'll also talk about things that we did with another game that we're building, which also uses Flask as well as other backend libraries. And I'm going to spend some time talking about different trade-offs that we had to make, decisions we had to make, and just share a whole bunch of random Gyaan, you know, around it. Now, as I go through it, right, one of the things, right, is, you know, you can spend a lot of time Googling for information, look up on Stack Overflow. But at least for me, one of the challenges I found with a lot of these resources is you don't quite always get insights into the sort of the thought process that goes into, you know, making some of those decisions. So hopefully we'll keep this sort of a little open, have a bit of dialogue around different things, and I'd love to hear from you about things that you guys are doing, and we can sort of share perspectives and insights. So the background for this talk comes from two things. Like I said, there was an Android app that we built out. We're about to launch the iOS version of this as well. And there's certain challenges that come with building a mobile app, right? Because unlike building out a website, here your APIs need to have backward compatibility, especially with Android. Users don't upgrade too often. So you've got to have multiple versions of this API available for older versions of the app. So these cause different levels of complexity. So this app is scaled up. We're now close to 200,000 active users. We're expecting that to double when the iOS app is released. The stack that we've used is Nginx, Unicorn, Gyaan, Flask. We're also using CouchDB, Redis, Postgres, and some of the other buzzwords that I'll get to, you know, as we go along. We're also building a game. We're building Antakshari Online. And with Antakshari Online, it's currently an invite-only beta, but we're using the same stack as well. So now, I do wish to sort of say that this talk, it's not about using Flask. So it sort of assumes familiarity with some similar platforms, and it's not about, you know, using REST API or using REST API with Flask either. There's this beautiful Flask RESTless extension, which you guys should look at if you're looking at that. So it's not about Flask, it's not about REST particularly. So it's really sort of the gamut of other things that we have touched, which we want to share and sort of open up dialogue with people. So what is it about? You know, it's around talking through some of these different trade-offs. So like I said, right, you know, we're in a situation where we started to build out this app. There was a great possibility that there were a couple of large carriers that might have sideloaded some of the apps with some of the devices they were shipping. So there was immense pressure on us to ensure that whatever we built out could be iterated on quickly and scaled up. And we had Django skills in-house. But, and I'm not here to sort of bash Django, because I think overall there are certain problem sets where I think it makes a lot of sense in certain areas, especially in the Indian context where it makes a lot of business sense as well. But we were looking for something lightweight which we could iterate on quickly, which didn't offer certain sets of constraints which could limit us. And certain types of constraints I think are good, because they make you think in certain ways, and I think those can be good. But when it's hard for you to sort of rev certain things independently, and especially in the mobile world, right, where things change every year, you've got a lot of pressure to be flexible and nimble around what you do. Now, I'm not here to evangelize any of these things that we're sharing. So these things work for us. They may or may not work for you. Okay, I'm going to take that back. There's one thing I'm going to evangelize, but everything else on this list, I'm not out here to evangelize, just to share it with you and share sort of why we went about it. And I'll leave it to you to sort of choose what you think makes the most sense at your end. So the first one, some of you are probably looking at it and thinking, oh, testing, BDD, TDD, God, this is boring, get me out of here, right? Now, I don't think I can sort of emphasize just how important this is. Because there's so many developers that I spend time with where testing is seen as important, but there's so much of front-end effort that you can put in with building automated test cases, planning for that really early in the cycle, which has such a huge downstream impact. One, it makes you as a team sort of accountable for quality of what you build, right? Second, there's less pressure on your QA team as well, with respect to what they could otherwise go on to focus on more. Third, right, it helps you model certain things and think through certain things really early on. With a lot of our code, right, early on as we were starting off, the test scripts that we were writing were much longer than the lines of code that we had. I think at the end of the previous talk, when Kiran was wrapping up, someone was talking about KLOC as a metric, and it no longer makes any sense as a metric, but I'll definitely say this, right? If your test cases are short as compared to your lines of code, you probably may not be thinking of all the scenarios well. Flask testing is an excellent extension. One thing we did is we set it up with continuous builds with Jenkins. So Jenkins, of course, as you know, lets you automate a lot of your build systems. Most people are familiar with it. And, we'd wire up test results to get published to our chat channels and different streams, depending on how things went. So we built out a large test suite so that the primary REST API was rock solid. We also ensured that CRUD was sort of being tested out separately. And one of the reasons it's sort of important is I think the nature of sort of what you're testing with REST and CRUD is a little different from the views and mashups that you might put together. So for instance, you've got an app or a web page where you built out the REST API for CRUD, and then there are different views for what's being rendered in each screen, right? What we found worked well is to test the CRUD APIs thoroughly with a set of nose tests, but to test views separately because often the performance needs of these views as well were a little different. So when you have mashups aggregating data from different sources, different API, pulling them all together, we found it useful to use blitz.io and to test performance on the views. And I'll just quickly show you, and on many of these slides, hitting down arrow takes you to more resources. So anyone here, just actually before I even get here, right, just a couple of quick questions. How many guys here use Flask? Thank you. How many guys here use Heroku? Right, Kenneth, that's a good number. Ah, you use Heroku too, good. What about Redis? Great. CouchDB? Or any NoSQL databases? Excellent, thanks, this is great. Anybody here using Blitz? Okay, good. So one thing that we did, right, is we wired up Blitz with Jenkins. So quick background about Blitz. Blitz.io is this awesome site, just give it a quick spin. You can go in there, point it to a URL, and it lets you run different types of performance test cases. You've got a concept of a sprint and a rush, through which if you want to sort of load test your APIs for certain scenarios, it works out really well. Now the nice thing about it is they've got this beautiful Python interface. So what's awesome about this? You can wire this to Jenkins too, right? So then on a nightly basis, or on a periodic basis, depending on what you think is appropriate, you can have these tests go through, collect performance information about how your API are doing, how fast your views are, And you can collate all that together and share that with your team so that this doesn't become an afterthought, right? Thinking of performance. It just sort of becomes an ongoing cycle with respect to what you do. Here's an example of sort of how Blitz IO's graphs sort of come in. They sort of let you look at response time, milliseconds, and let you sort of scale up the number of hits. So you can bump it up from like 10 concurrent connections hitting a server all the way up to 250, 300, and you can start to see where performance is starting to max out. The last thing in here with testing, right, is sort of building meaningful test data sets. And I think, this is probably simple enough, but I think it's often missed. But spending a bit of time sort of just populating either in a NoSQL database, in our case we use CouchDB, and just replicate it in test data, which sort of models some of the key scenarios that were relevant to us. We also had a Facebook web app. So we used the Facebook API to create test Facebook users and modeled various scenarios of different users being friends with each other, what impact that has on the social graph, and how this affects the data and queries that you're modeling. So I think the main point here is sort of just taking a bit more time to build out these data sets and working with that. So this slide, obviously Kenneth here bribed me to put this slide in, right? Well, Kenneth Reyes is from Heroku. He's down here. Welcome, Kenneth, to India. He's obviously going to be around today and tomorrow. Great opportunity to interact with him to learn a lot more about Heroku than I can possibly share in this slide. But what I will just quickly say is Flask setup on Heroku is a breeze. It's just awesome. You guys should totally use Heroku. I'm not evangelizing it again, but I will say that it's been awesome. We use Heroku for all our dev and test instances. So the neat thing about Heroku here, right, is, again, you can automate this. So with every significant change, we just go in and automatically create a new Heroku instance, populate all the data, replicate CouchDB data over as needed, and it makes it really, really easy for us to just continuously publish new instances. Now you might be wondering, why does this matter? Now it may not matter too much if you're running a website, but in our case, we're building APIs for apps, and we had beta testers, right? So you publish an app, they're pointed to one backend, and during that iterative cycle, you're not concerned about backend compatibility between small revs of nightly builds. So here, we just keep publishing a new backend on a new Heroku instance and a new APK or IPA, depending on Android, iOS, that you're sending out. So it lets you just continuously keep pushing things out and revving things as you go along. Single dynos on Heroku are free, which lets you get initial things going really quickly during this dev phase. As you know, Heroku lets you do a very simple Git-based deploy, which developers love. Gets a lot of the DevOps challenges which we would otherwise face sort of out of the equation for most things. Another awesome thing about Heroku, like I mentioned, we're building Antakshari Online. One of the things with Antakshari Online that we're doing is letting people sort of, when they sing, audio files get sent up to the server, a lot of it gets processed. But standard, Heroku instances don't have FFmpeg. But what Heroku lets you do is build out custom build packs, which is awesome, right? So it's easy to put out a custom build pack which has FFmpeg in it, and then use it with something like PyDub and apply transformations that you might want to do on your audio. So there's really, and you can correct me if I'm wrong on this, Kenneth, but there's no limits to some of the things that you can do here, apart from the fact that the file system itself is temporary. And if you need to store things, you need to publish that to S3 using Boto or something like that. A couple other awesome things. Heroku's Postgres support is just fabulous. It lets you fork data sets really easily. So one of the really neat, handy things here is when you're going through your early cycles, you can provide your product management team a link to various queries just off of the web, so they can get things where you can just fork a data set and let them run reports and watch it. Heroku also lets you fork instances from one zone to another. The default zone is the US, but earlier this year they introduced the ability to fork to the EU zone. So if you've got a lot of customers in Europe, you could set up an EU zone and fork over to run a separate instance there. The whole process of doing this is just so ridiculously simple. It's just so awesome to work with. Now, Heroku's great, but there's a few things which I'd love to see in there. One is an APAC zone. Like for instance, with the music game Antakshari, we're looking at a lot of Indian customers coming in. And obviously, latency here becomes a big issue with servers in the US or in Europe. So although Amazon's got infrastructure in Singapore, Heroku doesn't yet have an APAC zone. So latencies continue to be high, depending on which part of India people are and how the requests get routed. So it'd be great if Heroku adds APAC support at some point. That would be really neat. The other thing, which for some people might be limiting, at least it was for us in some cases, is lack of WebSocket support. Kenneth mentioned that this is coming soon, which I think would be an awesome addition. One other thing I'll add is, just a little thing. People, if you're just looking at Heroku, it may not be immediately obvious, but dev dynos idle every 30 seconds. And, obviously this doesn't happen in production. And if you're running in production, you should totally purchase a production dyno because their support and everything else that they do is fabulous. But in the dev cycle, to avoid these nodes sort of just going to sleep every 30 seconds, it's easy to just wire it up with New Relic. And New Relic will just let you ping that server every 15 to 30 seconds to keep that alive. Plus, New Relic is just fabulous for monitoring the data that the reports give you with performance of your API and how they're doing is just superb. So definitely highly recommend that. There's more resources in Heroku here, but I won't sort of get into this right now, but let you guys look at it. So the next thing is sort of this semi-philosophical question. I mean, there's a lot of debate now about opinionated frameworks, how people sort of think about some of that. Is small, big? Again, not here to sort of bash any of the bigger frameworks, but at least in our case, we were looking at something which would let us rev and iterate quickly. So there's a bit of a flip-flop, right? I think, when you go with a larger framework that's been around for a little while, you can find people in the market for your team who come with those skills a little more easily. It's easier to find training programs to train up your staff. But on the other hand, what happens is if you're a company that's trying to rev and build and grow fast, micro frameworks make a big difference. And here's sort of where Flask really helped us with building out sort of independent decoupled services with people responsible for each of these. And by revving each of these independently, it lets you grow fast, build fast, manage each of them separately. It does add some levels of complexity as well, but philosophically, right, I think thinking of this as being a model in which you can build things out, breaking it out, like, Kiran pointed out earlier, consider open sourcing some parts, so some independent services could be open sourced out, while the other decoupled ones could be the ones you keep in-house for certain reasons. Consider having all these services work over HTTP and exchanging JSON. Like Kiran pointed out earlier, some of the older people have considered using Pickle. There's a number of other data exchange formats we can use. But the flexibility of HTTP and JSON, which, for instance, CouchDB works completely over HTTP, and data exchange with the CouchDB database is all JSON. The other great thing that this offers, by just breaking it out this way, is sort of the ability to sort of refactor certain things separately if needed. The amount of regression you need to deal with if it's one larger system all packed together is a lot more. But if each is independent, it gives you a lot more flexibility to sort of be nimble, tune that, and make changes as you go along. And here's just one quick example. Right? So this is just a hypothetical example, but if you were to break out your backend for one of these games where you had authentication and auth running as one separate service, let's say using Flask with one of the OAuth modules along with it. Now, it's likely that you might sorry, am I too close to the speaker or something? Oh, okay. Okay, got it. So next, right, is if you're looking at building out real-time pub/sub, there's differing opinions about it. One school of thought, a lot of people who believe that Node.js is sort of the way to go, but you could even go with Gyaan and Socket.io, for instance, right, running on port. So if this is a case where you run with this for a certain while and you feel that, Node.js isn't that stable, I'm just going to switch back to Python, and I feel much more at home here. It gives you the opportunity to quickly switch back without impacting the other moving pieces that you have dependencies on. But you could continue to retain other parts which are decoupled separate, continuing to run in, for instance, Node.js and Express. The other advantage just decoupling some of this helps you with is you might find that you want to tune certain services for different scalability related challenges. For instance, certain things are more CPU intensive, certain things are more long-running, more of long-running requests, some of which make more sense to have deferred jobs for, and you could break those out separately. I'm not saying you can't do this if it's all sort of tied together more, but it's just a little harder because there's a sheer number of interdependencies that you end up having. The other little thing is just blueprints. You know, it's one of those little things in Flask which lets you, you think about it like a civil engineer, right? You draw blueprints, certain patterns for certain things. But where you find certain patterns, it lets you take a blueprint for an API scheme and register this against multiple endpoints. Oh, I'm sorry. Is it a mic problem? No, just me. Okay, I'll try to just look here when I speak. So with blueprints, right, what this lets you do is register various API routes for various endpoints, depending on, you know what, I'll just jump to an example. Lost my train of thought there. So this is just a really silly example, but you know, let's just say that there's this Bangalore-based well-known South Indian restaurant where the family decides, you know what, we'll split it into two, and one ends up being MTR, one ends up being Maya's. They both want to have a shop front, right? Now, what you could do if you're building out the backend for them and you've been managing it so far is you've got, you know, two routes, one for about, one for store. And this is just a very simple example, but it lets you sort of register each of these against a shop URL and manage it very seamlessly. I think this example doesn't convey the extent to which it's convenient Flask, but the amount of boilerplate required to manage sort of a SaaS-based instance is really low. So sort of in my last life, my company's consumer business ran a SaaS-based model. And the sheer amount of effort to run some of those SaaS-based models like 7 years back was huge. It was huge. It was a real pain. But the things like Flask, the ability to register these blueprints, manage each of these in isolation to do these is really, really convenient. So we are using delayed job queues. There's a number of options. A lot of people have recommended Celery. I personally found Celery a little harder to work with. Ended up just going with Redis and RQ. RQ is a package, again, which a simple, lightweight one, which lets you manage delayed jobs. So especially if you've got certain things which you don't want to let this slow down your primary API request. So for instance, sending email to people, right? What this lets you do is just quickly register when the API call comes in. Just register this in a queue of various jobs that need to be performed. And the API responds immediately, so your app or your website is more responsive. And meanwhile, these just get processed at the back end, depending on either on a schedule or depending on how you plan to handle that. So this is the one thing that I'm going to evangelize a bit. Redis is awesome. And there's a bunch of you here who are already using it. And I'd encourage everyone here to check out Redis. To me, it just blows my mind how awesome it is and the different things you can use Redis for. There's not enough time today to get into each specific example, but right away, right, if you're using Memcache anywhere, you could use Redis. You know, it's a great key value store which runs in memory, but also has persistence. So there's a bit of a misconception that Redis cannot persist data and is just in memory, which is not true, because I hear this quite often. Redis does let you persist data as one of the options in the configuration. So you can totally run it as Memcache. You can use it for server-side sessions. You might be using Beaker, you might be using some of the other things that are out there, but running Redis with server-side sessions is really simple to add in, especially with Flask. Definitely highly recommend that. Third, delayed jobs with RQ, like I mentioned earlier. Fourth is for PubSub, right? So PubSub lets you create real-time channels through which you can exchange communications with your website or app. Redis is really convenient. It's got these awesome data structures, you know. So one of the nice things to do these days, right, to make your app or websites responsive is to ensure that you aren't hitting your database too often. So for instance, what we often like to do is hit the database right at the beginning when things are loading up, because that's when the user is a little more forgiving, right? At the first time load, they're like, you know what, I'll give them an extra second. Once that's done, load up as much data as you can into Redis, and then use Redis' powerful data structures to do all the operations that you need to do right there. So do it in memory. Things are much snappier, and responses back to your app or website as well are much faster. So Redis has a number of things for managing stacks, queues, sets, lets you set up expiry times and various keys, which let you do a number of little interesting things. So definitely there's links to more resources, which you can refer to from the slides whenever you want to. I won't get into this a whole lot, but one beautiful little thing, I mean, decorators are common enough in Python, but I just felt like with Flask, the flexibility to use decorators in a very elegant way to do a number of things from returning, handling JSON-P, e-tags, with as little boilerplate as needed. And if you've got an API, for instance, for an Android app, which is what we started off with, and then we had to do iOS, and then we had a Facebook web app, it was easy enough to start off with just API that returned objects, and then from there sort of spit out JSON or HTML. We don't use a whole lot of server-side templating, so that we don't use Jinja a whole lot, because we prefer to sort of have single-page apps and do templating of the clients if needed. But in cases where you need to return other formats, it's quite convenient. I think just in the interest of time, I'll step forward here. How many people here sort of using Gyaan, Unicorn? Guys here? Cool. So one of the other reasons I'm so excited Kenneth's here is he's built this beautiful requests package that I think most of you, I'm sure, are using, even if you may not be aware of who Kenneth is. But when I first started off looking at Python, just the whole aspect of dealing with HTTP requests made me feel like, we're still back to the old days of using C and having a select statement and binding to a port, But requests just makes things so easy. So in case you're doing anything that requires pulling gets, posts, puts from the web, you should totally look at requests. The tagline is requests for humans, and I think it just makes things so awesome. And the nice thing is when requests and Gyaan play well together, this package called gRequests. In case you haven't looked at this, I'd just so highly recommend it. Since it's incredibly convenient, especially like you're building out REST APIs, you've got a number of APIs that pull a lot of data, and you want to do mashups, right? Now, it's simple parallelism, and you can spend a lot of time trying to create threads, pull these things together, but this makes it a breeze. So for instance, right, if you've got an API which returns to your app or website user profile information, and this collates data about user info, things that the user likes, some user-generated data like comments, certain assets he might have, Facebook graph data about his friends, what they like, what they've shared, and so on, right? Now, instead of doing this sequentially, one by one, fetching these with HTTP requests, the code to sort of take something like this and make it run with gRequests is incredibly light. It's just so convenient. It's really, really easy to take up existing code and just make it run in parallel, and so this is a simple example from Kenneth's site itself. Using gRequests, you've got a bunch of URLs to hit, and this is all that there is. To run these 5-6 requests together, get all the data back, and then you can do whatever you want with it. So gRequests has been incredibly awesome. I definitely recommend checking it out if you haven't already. CouchDB, right? So now, I think NoSQL databases, in my opinion, are slightly overhyped, right? I still think there's a huge value in sticking to traditional RDBMS, but there's certain problem sets. Like Redis has certain aspects where you're looking at doing things that are read-write heavy in memory. You've got certain problem sets where most of the things you're looking to do are heavy on reads. And CouchDB is a great fit for that sort of a problem. Now, fortunately, Flask plays really well with CouchDB. And it's all over HTTP, which is so awesome. And it's got 2 extensions. One that I'd say is good, Flask CouchDB. But Flask CouchDB kit is awesome. It's written by Benoit, the guy who's also built Unicorn. And it's been incredibly powerful. It's let us sort of manage and separate concerns really cleanly with CouchDB. And just, again, random Gyaan that I'm tossing in here. But with any NoSQL database, even with CouchDB, document conflicts are a pain to manage. And it's often the G-spot is sort of finding that little spot between having a lot of document types and having to manage a lot of relations. So you've got these 2 ends. A lot of documents, you can keep spreading things out, or you can have a lot of relations to manage, which is just hell. And finding the sweet spot in between is really important, whether it's Couch or Mongo or any of the other NoSQL databases that you're concerned. Couch apps have been really convenient because it lets you sort of push HTML and other assets that you have directly in as an attachment to Couch, separating those concerns out, but also managing it in a very neat way. I think in the interest of time, I'll just quickly move on. Now, I think 5 years back, many of us in prod were a little more discreet with respect to how much we would log, we would turn off logging. But today, with services like Loggly, and there's a whole bunch of similar services, Loggly is just one that we use, we pipe everything to Loggly. So we rarely get onto the prod servers to look at the logs there, but we use Loggly extensively because it lets you pipe up your app logs, web server logs, system logs, everything, you name it, up to Loggly, which lets you then go in via Loggly's web interface and either look at a live feed or to even look at historical data and look for patterns with respect to what you've been doing. Incredibly powerful. I'd highly recommend looking at some similar services. We also configured Nginx to log API service times. And I actually started to look at this because Heroku logs lets you sort of look at service times per request and just look to see if there's an easy way to do it in Nginx, and there was. So if you're looking at performance of the API, there's a quick little thing to just see how a request is doing. And you can collate this with New Relics data. And both combined together are incredibly powerful. Finally, exception tracking, there's a number of options. We tried 2, 3. Overall, quite honestly, Sentry has been our favorite. But exceptional, I think, has been great too. Some people use Airbrake. But Sentry has sort of been our favorite overall with the ease of use and the data that has been providing us. We also use SendGrid quite a bit, which is a service that lets you send emails. So for a lot of our worker jobs or things, when they have certain critical issues, we just use SendGrid to send out notifications. Now quickly, this is just a bunch of different Flask extensions. I'm not going to go into each one of these. A lot of them are online. Couple which you may not have heard of that I'll quickly call out. One is Flask Split. Flask Split essentially lets you do A/B testing. It's awesome because often a challenge, and this doesn't apply to an app, but for instance, for a website, one handy thing is sort of just get a feel for how people are responding so you can iterate quickly. So you want to have a button in one position or in a certain type. Doing A/B testing with Flask Split is really convenient, and it lets you track multivariate results and then figure out how things are going. Next, I'll quickly talk about Flask Script. This is primarily intended for management commands, that you can run. Now, the funny thing is, we ended up using Flask Script a lot internally since we had a lot of junior developers. And it was sort of a team management thing of trying to see how we could segregate things junior developers could do. So we essentially had them work with Flask, but outside the request context, working on view-related mashups, where the more senior developers in the team handled REST-related CRUD. And Flask Script is really handy because you can have them work in an isolated context, building views continuously, running them, testing them with delayed jobs, and view wrappers. So very handy. Just a little tip I thought I'd share with respect to what we do. So quick recap, the Flask docs are fabulous, right? Documentation that Flask has is really, really useful, beautifully done. Now, not a lot of docs and sort of how do you scale this app, how do you grow it, how do you think about some things beyond just building a simple app or a simple site. Now, this was hard to find, which is partly why I tried to aggregate a lot of this together. Lots of help on the IRC channel, definitely worth spending some time there. A few things to keep in mind, not all popular extensions are listed. I'm not sure why this is the case, but a lot of popular extensions are not on the list on the Flask site. Also, not all the listed extensions are stable. Had a lot of pain with some of the extensions where we hit a number of issues, tried to collaborate with some of the developers. There's one where we're likely to just fork and try to take one of the cache invalidation challenges we're having to just fork off and contribute back to that extension. But just a few gotchas to watch out for. Finally, don't hesitate to just rewrite something. I personally think that in today's world, you've got to rewrite certain things probably every 2 years. It's probably just a healthy practice to just go back, look at things, just plan for rewriting. It's just going to happen. And automate early, automate often. Just a little shameless plug here, but we are hiring. We're looking for awesome Pythonistas and mobile devs. My slides are online here in case you'd like to look them up. And a quick thanks to the guys who helped me with the slides, Vinujay, Kiran, and all. So with that, just open Q&A. Not a lot of time, but I welcome people to sort of share their experiences too with similar stacks.
This is like less of a question, more of a comment. So we also use Redis heavily. The thing that we saw that Redis keeps everything in memory, persists via snapshotting. So if it crashes, then you may lose data.
Yeah.
So the thing is like it's excellent, and you should use it to store sessions and cache things and things like that, which you could recover from.
Yeah.
But don't put data that
Correct.
You will lose.
Yeah, absolutely. Completely agree. So I'll just quickly recap what you said in case people didn't hear it. Don't put things in Redis that you're worried that you might lose in case of power outage or challenges like that. So if you're building a financial application, putting all that in Redis and depending on it may not be great. If you're, for instance, building a game, you don't mind having all the game data and memory there, that's a good fit. Good point. Agree with that. Okay? Grace?
Hi, this is Siddharth from iVisualize Tech.
Hi, Siddharth.
One of the things that you said you have been using Flask from the beginning. Did you try other Python-based frameworks like Django and others before switching on to Flask, or Flask was the default thing which you started?
No, great question, right? So yeah, I used Django earlier. So used Django earlier, like Django, right? A lot of benefits, a lot of positives for Django. From a business standpoint, you're looking at building something out, it's easier to find people with Django skills overall. Now, pretty much the first iteration of this whole backend, until we got like about 10,000 users, I'd built the whole system myself. So I was sort of the one-person team building the whole thing out in the backend. And I wanted the ability to like be nimble and iterate quickly and break things out later with new people who come in. And looking at micro frameworks, Flask was just awesome. So the docs are great, getting started was real quick, and I felt I had more flexibility. There's obviously a number of other options there between Bottle and Lepiva and others. So not that Flask is the only answer. So not evangelizing any of these specifically. I'm just trying to share why we chose these. Your mileage may vary, and you're obviously free to choose something different. No. Went with Flask all the way. But I've used Django in the past for certain websites. But for building this, just went with Flask all the way. And it's been super.
Hi,
Hi.
Sebastian Ritter, Debizzle.com. Hi.
Hi.
Just a quick question, a more general question really about your API designs. We're currently in the process of moving to software or service-oriented architecture as well. And we're finding that the more and more we decouple our services and create more smaller and smaller services, we're creating more interdependencies between the APIs. And I was just wondering what your opinion was on sort of using HTTP between APIs that are then calling other APIs, and how you're managing sort of maybe just reusing Python as libraries as opposed to as their actual APIs.
Yeah, I think this is a little subjective. If it's okay, can I take this offline later with you and dig into that a little more? I think it's a little hard for me to sort of answer that without more context.
Last question.
Hi.
Hello, this is Nischal here. Firstly, great talk.
Thank you.
The thing is, now you've been using Redis and you've used CouchDB, but let's say you're building an application that requires a lot of data to not just the gets, but the posts. How would you handle that? For example, the current app that you're building, the Antakshari one, would probably require a lot of data to flow through the network and go to someone else. So how do you plan on handling that with this particular stack that you have?
Yeah, it's a great question. I'd say CouchDB is not great if you're looking at a lot of writes happening. Now, Redis is great, right? But like the other guy pointed, it's not great if you've got a lot of things in memory and you're concerned about issues. Now, specifically on Antakshari, what we're doing here, it's not as much of an issue because with games, you can have all the data being exchanged, and we just have delayed jobs, workers that then later archive it to a traditional database. So then you've got that safety of doing that delayed without the constant hit. So for instance, companies like Zynga who use similar systems, they just have periodic systems just go through and then write to disk. Because at a time in memory, right, you can't be worried about all that and going and hitting the database. So, sure. I'm available. My Twitter ID is here. Please feel free to contact me offline if you've got any further questions. And I can catch up with you. Thank you, guys.